So hello everyone, in this video we are going to discuss about the permutation ciphers. So permutation cipher has some permutation. Let's say we take a window size, let's say m is equal to 6, and then this is key. So this key is having some permutation, let's say pi. So for x 1 2 3 4 5 6, because we have 5 window size is 5, so we have up to 6 numbers, and then this permutation says it is 3 5 1 6 4 and 2. This is not required, just a minute. Okay, and this is our permutation P, and then we take the inverse permutation also. So this is pi inverse, this is pi, and this is pi inverse x. So this is for encryption and this one is for decryption. Now let's say our text is how we are going to do this, use this permutation cipher. So let's say the text is defend the hilltop at sunset. So when we use this defend the hilltop at sunset, so what we do, for the first thing is we divide this plain text into the group of 6 6, because our window, we take here window size is 6, so into the 6 alphabets. So let's say this is the first one, this is going to be the second one, this is going to be the third one, and this is going to be the fifth one. So let me write it by combining it. Defend the HILLTOP at, and then sunset. So this is going to be x1, this is going to be x2, this is going to be x3, this is going to be x4, this is going to be x5, and this is going to be x6. Now it goes to x pi 1, permutation pi 1, this goes to x pi 2, this goes to x pi 3, and so on, x pi 4, x pi 5, and x pi 6. So what does it mean? It means x1, what is the x1 says? It says go to the third one. So what is the third one is? Third one is f. We are just permuting it. So the x3 is f. So in place of x1 we are writing x3, which is f. Now x2 is goes to 5. So in place of x2 we are going to write x5, which is n. Then it is x3. So x3 says in place of x3 you need to write x pi 1. So what is x pi 1? Which is d. Again x4. So x4 says in place of x4 we need to write x pi 6. And what is x pi 6? It is again d. Then in place of x5 we need to write x pi 4. And what is x pi 4? It is e. Similarly, in place of x6 we need to write x pi 2, which is again e. So this is for first one. So it means this is, that's why this is called permutation cipher. So again this is a polyalphabetic cipher, because every time a single letter can be moved to another one, because it depends upon the position, at which position the letter is. Okay, so let me write it for one more time so that the things will be clear. So let's write it for sunset. So x1, see here this e is d, and n is also e, and d is also e. So this is again, so x1, then x2, then this is x3, this is x4, and this t is x5, sorry, this is x3, this will be x5, and this will be x4, and this is x6. Now this is x pi 1, this is x pi 2, this is x pi 3, this is x pi 4, this is x pi 5, and this is x pi 6. So now what is x1? x1 is going to x by 3. And what is x by 3 here? N. So it will be n. Then what is x2? x2 is going to x by 5. And what is x by 5 here? It is e. Similarly, x3 is going to x by 1. And what is x by 1 here? It is s. Similarly, x4 is going to x by 6. And what is x by 6 is here? X by 6 is t. Similarly, x5 is going to x by 4 and x by 4 is s. And x's is going to x by 2 and x by 2 is u. So this is how we are going to encrypt it. So this is again a permutation cipher. This is an example of permutation cipher where we take window size is 6 and this is one permutation. 1, 2, 3, 4, 5, 6. So if this type we can write many permutation. It depends upon the window size 6. If it is 6, then we can write more than factorial 6 permutation here. So it is something like, now this is our encryption. This is our cipher text. If we want to move again with the cipher text to the plain text, again it is going to x1, x2, x3, x4, x5, x6, and this is x by 1. Now we will use the inverse, x by inverse 1, x by inverse 2, x by inverse 3, like this. Now we will use the inverse permutation. Like for example, x1 goes to 3. And what is 3 here? Pi 3 is d. Then again x2 goes to 5. And what is x by 5 is e. So it comes out to be defend. So this is how we can encrypt the permutation ciphers and how we can decrypt the permutation cipher. Next example of polyalphabetic cipher permutation cipher is Playfair cipher. So how we do this Playfair cipher? So let me write it first. Playfair cipher. This is again a polyalphabetic cipher, and in this Playfair cipher we make a key matrix, and key matrix is going to be 5 into 5 matrix always. For whenever we are using Playfair cipher, we make a key matrix, and this key matrix is always going to be a 5 into 5 matrix. Doesn't matter what is the key. Okay, so let me write a 5 into 5 matrix here. So let's say this is our 5 into 5 matrix. How we are going to fill this matrix and how we are going to encrypt and decrypt using this matrix. So now we will have a key. So let's say for this 5 into 5 matrix, our key is, let's say key is Charles. Okay, so whatever is your key, it can be cipher also, it can be Charles, whatever is your key, doesn't matter. Write that key first. CHARLES. So this is our key. Now it is 25, because it is 5 into 5 matrix. So we have 25 cells in a 5 into 5 matrix. So, and we have 26 alphabets. So as a rule we write I and J in same alphabet, in same cell. I and J will go to the same cell. Now starting from ABCD, we will fill this matrix, and whatever as we have already written, we are not going to write that. For example, A is already there, I write B. C is already there, I write D. E is already there, F, G, then H is there, I. Now when it comes to I will write I and J in same. Then K, L is there, M, N, O, P, Q, R is already there. S, T, U, V, W. I think we missed something. B, D, F, then G. Okay, S is already there, yes. So it will be T, U, and just a minute. So T U V W X Y and Z. This is how we are going to fill this matrix. So this is now key matrix. Okay, so everything whatever we are going to do, we will do with the help of this key matrix. So it is very important to write the key matrix correctly. This key matrix does not allow any repetition. Repetitions are not allowed. Repetitions are not allowed means a single letter cannot come twice. So for example, in your K, there is a letter which is come twice or thrice. You will write it only one time. For example, your K is going to be this L-I-L-L-Y. So now this K becomes L-I-Y only. You will fill only 3 cells with K. No repetition is allowed. For any kind of repetition is not allowed. Now how to encrypt using this key matrix? That is a trick. So for example, if let's say how we are going to do encryption. So let's say what we do, we divide every the complete plain text into a group of 2 letters. So for example, here our plain text is, let's say I write a plain text, meet me at the bridge. Okay, so meet me at the bridge. Now let me divide it into a group of 2 letters here like this. And because this E is like separate, like it is like that, me, double E-T, me at the R-I, then D-G, and then E alone. So what if something is left alone, fill it with X. If something is left alone, fill it with X. Now how we are going to encrypt this? This is a trick. So there are some rules. For example, if both the letters are in same row. If both the letters are in same row. For example, E and B. Just see this matrix. E and B are in the same row. So we are going to replace it with next letters. Like the letter next to E is S and next to B is D. So EB is going to be replaced with SD if they are in the same row. For example, E and F. So E will be replaced with S and F will be replaced. It's around like circular operation. So S will be replaced with E. This is the first thing. Second is if they are in the same column, then also we are going to replace them with next letter. If in the same column, then also we are going to replace them with the next letter. For example, D and T. This D and T are in same column, so D will be replaced with M and T will be replaced with Y. For example, T and the second example is T and Y. So T and Y are in same column, so T will be replaced with Y and Y will be replaced with R. Now the third is if they are in the different row and or different column. They are different row and different column. Different row and different column. So for example, M and E. Now M and E are in different row and different column. So what we will do, that we are going to take an where it cuts. Like for example, M cuts to E at G and E cuts to M at D. So M will be replaced with G and E will be replaced with D. This M will be replaced with G and E will be replaced at D. So this is how, for example, let's take another example, G and K. So for example, G and K. G is here and K is here. So this is something else, because how we can replace, because I and J are in same column. So here either you can write I and M, or you can write J and M. Both are okay. So both are okay. So this is how we are going to do the encryption. If they are in the same row, again I am repeating, if the same row, the next letter like E and B. If they are in the same column, then next letter. If different row and different column like E and M, we use the intersection. So E is going to like intersect this row of M at G. So M will be replaced with G, and M is going to intersect this column of E with which is with E, with D. So M will be replaced with D. So let's encrypt the whole message. So in the next page I will make this key matrix again. So it is going to be a 5 into 5 matrix. So let's write Charles. You can write any key. Okay, now I'm going to fill it B, C, D, F, G, I and J, K, L is already there, M, N, O, P, Q, R, R is there, S is there, T, U, V, W, X, Y and Z. In the same plain text, meet me at the bridge. So because E is alone, we are going to fill it with X. The rest all are in the group of 2. So now we check for ME. So ME is just M and E are different. So M will be replaced with G and E will be replaced with D. So this we have already done. In the same here also, M will be replaced with G and E will be replaced with D. Now E and T. So E and T are also in different rows, different columns. So this T will be replaced with O and E will be replaced with D. So sorry, E will be replaced with O and T will be replaced with D. Then at this AT is again going to be replaced with A and T. A is here and T is here. A is going to be replaced with Q and T is going to be replaced with R. Then T and H. So T is going to be replaced with P and T is going to be replaced with P and H is going to be replaced with R. Then E and B. E and B is going to be replaced with S and B is going to replace with D. R and I. So R is going to replace with M and I is going to replace with H. D and G. So D is going to replace with M and G is going to replace with E. Then E and X. So E is going to be replaced with V and X is going to be replaced with B. So this is how we are going to encrypt using Playfair cipher. So this is how the encryption is done in Playfair cipher. And decryption is also like we can do in the same manner decryption also, that I am going to discuss in a separate video. So again in some video I will discuss with some more example with Playfair cipher with encryption and decryption. Thank you.